Hey, everybody, and welcome to this most exciting screencast on the Sine Law. Okay, so this is something that we've been working on for the past couple of days, and what we'll do is we'll kind of finish it off here with a couple of examples. Okay, so in this one here, we started this one up last week, and I believe we left off with the following. So when you have a non-right triangle, if you can pair off a side and an angle. So that is the side is sort of adjacent to that angle. And you can pair that up with another pair of information such that you have a side that's adjacent to an angle. You can create a sine law relationship, or what we've been calling a height equation. So in this case, C multiplied by the sine of 70 degrees is equal to 12 multiplied by the sine of 45 degrees. Okay? So we can go ahead and solve that successfully and get the length of side C. Okay? Now, before we do that, what I would like to impress upon everybody is the following. There are situations where the triangle you're using, the way it's set up, like its orientation, the sides and angles you're given, it's sometimes not fully clear if you can use the sine law. So what I'm going to suggest is the following. If you take a look here at this table, okay, so this table we could use to organize our information. So for instance, okay, so angle A is 65 degrees, side A we don't know, B is given as, what do we have there, 12, right, that's side B here, and its opposing or opposite angle is 70. Side C, well, we don't know. And then angle C is given as 45 degrees. Okay. Now, the neat thing with the sine law is one way you can tell is if you're using this style of table, all you need to look for is a bit of a crisscross pattern. So, for instance, notice that 12, the length of B, okay, can crisscross over with 45 and the length of C with 70. Okay? So if you see that, okay, you are able to use the sine law. Okay, and here's another one. In fact, if you were after side A, what we could do, let's just slide that up, is you could use this pairing of information. Okay, so you have three unknowns and one unknown. You can solve for A. But in this case, we're going to try to solve for side C. So where am I going with this? Well, I do have to share something with you. When you're using that table as an organizer, here's the style of equation that you'll want to be using. Okay, so let's see. Let's back up a little bit. Yeah, let's go here. Perfect. Just going to get rid of that height. So pull that out of there. And we'll get rid of this here. Not worried about that. But what I am worried about is the following. Okay? So I'm going to label one more side on here with angle C and side C. So in any non-right triangle, this is true. Okay, absolutely, hands down. So the ratio of angle A, that is its sine, compared to its side length, is always equal to the following. So the sine of the angle B to side B. And then that's also equal to the sine of angle C to side C. Okay? So from this, what you can imagine is that I could set up an equation involving only A's and B's, and I could solve for any one of those, right? I could solve for A, B, A or B, but I would have to have any three, okay? Also, you could end up solving for, right, if you had this information, right? So this equation implies that I could solve, I could solve for any one of these, right? Provided that I have three pieces, and from that I'm only looking for one. Or what we could do is you could make this equal to that, okay? And in that case, you could solve for a, C, little a or little c. But it depends on which 3 you have and the one you're looking for. So if we go back to the example, the sine law equation we can use, right, is going to be the following. So have a look at this row here. So we're going to take the sine of b compared to b, and that's going to be equal to this. So the sine of c to c. Okay. Now at this point, we can substitute in our information. So we have sine 70 is related to, let's see, it's sine length of 12, and that's equal to the sine of 45 compared to the unknown length. In this case, the length of c. Right? Now, previously to this, when we solve, what we would do is we would cross multiply. So we end up with, let's see, c times the sine of 70 equals 12 times the sine of 45. And you might notice, here's what's interesting, is that what we started with back beforehand, we'll call it the old days, is the same expression we have here. Okay. So again, you might want to start using this one, okay, in those cases where it's not so easy to tell if the sine law is applicable. Okay. And last but not least, we go ahead, we start solving. Okay. So let's divide out the sine 70 from both sides, because that way we're going to isolate c. Okay. Okay, so sine 70 divides into itself one time, and we're left with c equals this tidy expression. So all we need now is a calculator. So let's give this a whirl. So using the calculator and a set of parentheses, I'm just going to clear this out. So I'm going to start with the sine of 45, and notice I'm in degree mode. I'm going to multiply that by 12 and hit equals. So I now have the answer for the numerator. Okay, so let's go ahead and divide by the denominator. So we'll divide by, we'll open up brackets, make sure it's following BEDMAS correctly, pressing sine, closing that bracket off. Now we have the answer to the bottom. Last but not least, press equals. And we end up with about 9 units. Okay, so in this case, I don't think any measurements were given. Oh, there were centimeters. So we have about 9 centimeters in terms of the length of side A. Okay, and that's specifically how you operate with the sine law. The only other thing you might enjoy doing is the following. I know some people like to do substitutions right away. So instead of doing it this way, if you wanted to substitute that in right away, you could. And then if you want to sub that in for the sine of 45, you could do that and then calculate. Okay. Just be careful that you get yourself enough decimal places, at least 4, so that when you're rounding, right, you're really not overly rounding the answer. All right, that's it.